Hello to the tech community out there, and welcome to this episode of Tech with Crado. My name is Chris. In this short video, we're going to look at how to handle AWS eventual consistency error in Terraform. What is eventual consistency? It's basically an asynchronous consistency model that maintains data availability across distributed system. And the way it's implemented in AWS is that AWS infrastructure is decoupled into a control plane and a data plane where all API requests for creating, reading, update, delete, and list resources are sent to the control plane, and the execution is implemented in the data plane. With this model, it means that it takes some few seconds for a resource request to be propagated into the data plane. And most of the services that are affected by that are AWS IAM, S3, EC2, EMR, Redshift, DynamoDB, SNS, and SQS. What is the impact of that on Terraform? Basically, due to the delay of those resource availability in the data plane, you may be required to run Terraform apply more than once in order to create certain resources. Obviously, if you're running Terraform apply manually, this may not be an issue, but in a pipeline where everything is automated, this can become a serious nightmare to deal with. The good news is that Terraform has a resource block called time sleep that allowed us to actually implement that delay when necessary. Now let's jump to a demo and see how we can actually implement such delay when needed. Let's start by cloning our repo that we're going to use for this exercise. This is actually Mechanisys Firehose module that is intended to do a couple of things. First, it's supposed to create an S3 bucket, a Firehose stream, an SNS topic, and an IAM role that will eventually be assumed by SNS service to create a subscription of the Firehose stream to the SNS topic. Okay, if we look at our codes, this is the Kinesis resource to be created, the SNS topic, the IAM role, and then finally create a subscription that will make use of this IAM role to subscribe the Kinesis Firehose to this SNS topic. Let's now go to the command line and execute the creation of these resources. Let's run Terraform init to initialize the module. Then Terraform apply. This is going to create 7 resources. Now we say yes to this and wait for the resources to be created. This may take some few seconds or maybe more. And suddenly we got an error. Yes, an error that indicates that the IAM role that was created some few seconds earlier is not a valid one to be assumed by SNS for the creation of the SNS subscription. It's clear that this is not true because right above here we could see that this IAM role was created successfully. We can also confirm that by taking a look at Terraform state file by combining Terraform state list and Terraform state show command. Here is the ARN of the role despite it being declared invalid. And this is just a consistency error, and if we run Terraform apply for a second time, this resource will be created without any issue. Now this subscription has been created successfully without making any change to our code. Obviously, when running Terraform manually, this is not a problem, but if used in a pipeline, this could result into a frequent failure of your pipelines. The best way to resolve this problem is to first review the error message you got to actually identify all the dependency and then introduce a time slip or a delay within those execution. Now let's destroy the resource we created earlier, update our code, and rerun Terraform apply and see the difference. Now we're going to introduce the time slip. This is to introduce a 30-second delay after the creation of the Firehose IAM role and the Firehose stream. We also update the subscription to only execute after 30-second delay. Let's now go to the terminal and run Terraform init, Terraform apply with auto approve. This time we're creating 8 resources. Now we have the Kinesis stream that is being created. And now we have the time slip that starts. After 30 seconds of waiting, our SNS topic subscription got created without any error. And this is how you overcome an eventual consistency error within your pipeline with Terraform. This brings us to the end of this episode. If you have any question, comment, or contribution, type it in the comment section. And if you find this video very useful, give us some like and don't forget to subscribe to this channel. Thank you for watching and see you in our next episode.